This video is Python Crash Course Chapter 6, Section C, Nesting. Sometimes you'll want to store a set of dictionaries in a list or a list of items as a value in a dictionary. This is called nesting. I like to think of nesting like the nesting Russian dolls. When you open one, there's more inside. In this case, you're storing or nesting a set of dictionaries inside a list of items inside a dictionary, or even a dictionary inside another dictionary. Nesting is a powerful feature, as the following examples will demonstrate. The Alien Zero dictionary contains a variety of information about one alien, but it has no room to sort information about a second alien, much less a screen full of aliens. How do you tell your program to treat all of these aliens in a similar way? One way is to make a list of aliens in which each alien is a dictionary of information about that alien. For example, the following code right here builds a list of 3 aliens. Now I can loop through all of my aliens. As you might expect, the output is the full dictionary for that list item. As we learned in the last section, you could add some other loops and some other print statements to pull specific pieces out of that dictionary, but for this code, all we wanted was the whole dictionary. Here's a more realistic example. We've got more than 3 aliens. In fact, we've got code that's going to generate 30 aliens. We're using range, which we learned about back when we talked about lists, to create a fleet of 30 aliens. So we begin with an empty list to hold all of the aliens that are going to be created. Here's range, returning a set of numbers, which just tells Python how many times to repeat this loop. Each time the loop runs, we create a new alien. And then we append each new alien to the list aliens. Here, we use a slice to print the first 5 aliens. And then here, we print the length of the list so we know that we've created 30 aliens. Here's a piece of that output. The 3 dots here simply mean that we've cut the code off. It would go on 30 times, and that would not fit on our screen. Because this is a list, the aliens wouldn't have a name like Alien 1. Instead, they would be the alien located at an index position within the list of aliens. So you could access it by using alien bracket 1. So, with just a few lines of code, we can create a really large number of elements in a game or program. You could then tweak them as the game goes on. For example, if alien bracket 3, remember, the alien at index 3 in the list of aliens, is hit, you might change its speed to fast or its color to orange. These aliens all have the same starting characteristics, but Python considers each one a separate object, which then allows us to modify each alien individually. How might you work with a set of aliens like this? Imagine that one aspect of a game has some aliens changing color and moving faster as the game progresses. When it's time to change colors, we can use a for loop and an if statement to change the color of aliens. For example, to change the first 3 aliens to yellow, medium speed aliens worth 10 points each, we could do this. Because we want to modify the first 3 aliens, we loop through a slice that includes only the first 3 aliens. All of the aliens are green now, but that won't always be the case. So we write an if statement to make sure we're only modifying green aliens. If the alien is green, we change the color to yellow. The speed to medium. And the point value to 10. Here's that output. Notice that only the first 3 are changed. This feels like something I have encountered before. Some games start out with slower enemies, and then they get faster. Some games give you enemies that are identical but move at different speeds. Some games give you different points for different characters. This seems really complex. And until reading this chapter, you would have been creating each individual alien. Dictionaries allow you to do a whole lot of detail a whole lot faster. So perhaps coding a game like Mario or, well, maybe Fortnite might not be quite so hard as you thought. You could expand this loop by adding an elif block right here that turns yellow aliens into red aliens that are fast moving and worth 15 points. Without showing the entire program again, here's what that loop would look like if we printed it out. Oops. Sorry, not actually there. I'm sure you can imagine what that would look like if we printed it out. So, using just these few lines of code, they would completely change how complex your game could be. It is common to store a number of dictionaries in a list when each dictionary contains many kinds of information about one object. For example, you might create a dictionary for each user on a website, as we did way back in our user program last section, and store the individual dictionaries in a list called users. All of the dictionaries in the list should have an identical structure, so you can loop through the list and work with each dictionary object in the same way. And that's really the point of storing dictionaries in a list. That list structure allows you to loop through all of your dictionaries and deal with potentially a huge volume of data relatively simply. Rather than putting a dictionary in a list, sometimes we have to put a list inside a dictionary. For example, consider how you might describe a pizza that someone's ordering. If you were to use only a list, you would be stuck storing just a list of the pizza's toppings. With a dictionary, a list of toppings could be just one aspect of the pizza that you're describing. In the following example, 2 kinds of information are stored for each pizza: a type of crust and a list of toppings. The list of toppings is a value associated with the key toppings. To use the items in the list, we give the name of the dictionary and the key toppings, as we would any value in the dictionary. Instead of returning a single value, we get a list. We begin here with a dictionary that holds information about a pizza that has been ordered. One key in the dictionary is crust, and the associated value is the string thick. The next key, toppings, has a list as its value that stores all of the requested toppings. Here, we summarize the order before building the pizza. accessing the value at the pizza crust key. And here, all the way down here, we're printing the toppings. So this will print one kind of statement about what this pizza looks like. You can imagine throwing that on a screen for a user to confirm their order before you start making the pizza. Notice here we're using one key in the dictionary, here we're using another. We're looping through toppings because toppings is a list. Surprised? Here's what that output looks like. You can nest a list inside a dictionary anytime you want more than one value to be associated with a single key in the dictionary. So here's our familiar languages program. If we were to store each person's responses in a list, they could choose more than one favorite language. When we loop through the dictionary, the value associated with each person would be a list of languages rather than a single language. Inside the dictionary's for loop, we use another for loop to run through the list of languages associated with each person. So here, the value associated with each of these names, well, that's a lie. The value associated with Jen and Edward and Phil are lists. The value associated with Sarah is still a list, has one item in it, but it's still a list. When we loop through the dictionary here, we use the variable name languages to hold each value from the dictionary because we know that each value will be a list. Inside the main dictionary loop, we use another for loop down here. Notice how these are nested. There's the first line and then a print statement and then the next line nested in this for loop. This for loop runs through each person's list of favorite languages. Now each person can list as many favorite languages as they like. We could print out Jen's favorite languages or Sarah's favorite languages. You can nest a dictionary inside another dictionary, but your code can get complicated quickly when you do. For example, if you have several users for a website, each with a unique username, you can use the usernames as the keys in a dictionary. You can then store information about each user by using a dictionary as the value associated with their username. In the following listing, we store 3 pieces of information about each user: their first name, last name, and location. We'll access this information by looping through the usernames and the dictionary of information associated with each username. We first define a dictionary called users with 2 keys, one each for the usernames A. Einstein and M. Curie. The value associated with each key is a dictionary that includes each user's first name, last name, and location. Here, at 1, we loop through the users in the dictionary. Python stores each key in the variable username, and the dictionary associated with each username goes into the variable user_info. Once inside the main dictionary loop, we print the username on the second line. At 3, we start accessing the inner dictionary. The variable user_info, which contains the dictionary of user information, has 3 keys: first, last, and location. We use each key to generate a neatly formatted full name and location for each person, and then print a summary of what we know about each user. Notice that the structure of each user's dictionary is identical. Although not required by Python, the structure makes nested dictionaries easier to work with. If each user's dictionary had different keys, the code inside the for loop would be a little bit more complicated. Remember, we're printing full name and location rather than pulling that out of the dictionary. We're using that as a string. So if it were something else, that would be a little bit more complicated. And here are your assignments for Chapter 6C. There are a lot here. In this chapter, you learned how to define a dictionary and how to work with the information that was stored in a dictionary. You learned how to access and modify individual elements in a dictionary and how to loop through all of the information in a dictionary. You learned to loop through a dictionary's key value pairs, its keys and its values. You also learned how to nest multiple dictionaries in a list, nest lists in a dictionary, and nest a dictionary inside a dictionary. In the next chapter, we'll be learning about while loops and how to accept input from people who are using your programs. This will be an exciting chapter because this will make all of your programs interactive and they will respond to user input. But before we go there, make sure you do 6.7, 6.8, 6.9, 6.10, 6.11, and 6.12. Happy coding!